Today we're going to talk about linear equations in two variables. So the first thing to recall is that a linear equation in one variable typically is in the form a number times x plus b equals 0, where a would not equal 0, otherwise you wouldn't have that variable x if you had 0 x's, right? So if you see x by itself, what's its coefficient usually? If I just wrote something like x plus 5 equals 6, let's do 16 actually, what would be the coefficient, the number in front of x? 1. So here we're saying if the coefficient were 0, then you wouldn't have an x because 0 times x is 0. And then you would just have b equals 0. Typically, this equation has one solution, but we did talk about in previous lessons, I put an asterisk here because it could have no solution, also could have infinite solutions. But if we were going to solve this equation for x, what would you do first if you had 3x plus 15 equals 6? Take a moment and try and solve that, and then we'll discuss your solutions. So I'm going to give myself a little more space. And what did you do first? Okay, you subtract 15 from both sides. You get 3x because 15 minus 15 is 0. 3x equals, and what's 6 minus 15? Negative, is it negative 9? Right, because 6 minus 15 would be negative 9, right? Because you have 6, you owe 15, and then what would you do to get x by itself? X equals negative 3, and we could put that in set notation because we were talking about set notation last time. Negative 3 is the solution set to this equation. How do we make sure that that's actually true? Hint. Check. And to check it, we would plug that number in, negative 3 plus 15. We want to see, is it equal to 6? We get negative 9 plus 15. Is that equal to 6? If you owe 9, you have 15. Pay back your debt. You have 6 left. 6 equals to 6. So that's how we know. 6 is not our solution. Negative 3 is our solution. And what I showed right here is just set notation, showing that that is our solution set. Any questions about remembering how to solve a linear equation in one variable? Okay, well, the next thing we're going to do today is look at linear equations that have two variables. So we call this the standard form of a linear equation in two variables. A number, that's why we're using A, times x plus a number, B in this case, a different number, times y equals c. The solution to an equation in two variables will be an ordered pair, and spoiler alert, we're getting ready later on to graph this. And that's the reason why we're going to call these linear equations, is because if I graph this, I will actually get a line. And a lot of you have graphing calculators, and that's going to be helpful. An equation in two variables will have an infinite number of solutions, infinitely many solutions. Okay, so here's an example right here. Find 4 solutions to the equation 3x plus 2y equals 6. Write the answers as ordered pairs to complete the table. And the ordered pair, it actually goes in order. X comes before y. And so here we're saying if x is 0, what is y? So in order to find out, we're going to take x and we're going to plug 0 in. So 3 times 0 plus 2y equals 6. Now that I have replaced the x with a number, I can actually solve for y, because I can't solve if I have both of them as variables. So what would you do first to solve for y? Well, we could multiply 3 times 0. And what is 3 times 0? 0. So the only thing I have left is 2y equals 6. How would I get y by itself? Divide by 2, and I get y equals 3. Does everybody see where I got that? Okay. By the way, when we substitute x is 0 and I'm going to put it into a table of values. I'm going to show you in a minute how we might put this table, how we can generate this table on our calculator. We call this, whenever x is 0 and we get a y value, we call this the y-intercept. And I'm just bringing that up now. We don't really have any context for what does that even mean, but we're going to be coming back to that when we get to graphing this as a line. Okay, so for the next one, this one says if y is equal to 0, what is x? So the same way we plugged in x was 0, now we know y is equal to 0. And so we're going to put y, 0 is y here. So we have 3 times x plus 2 times 0 equals 6. And we want to solve for x. So what is 2 times 0? 0. So if that's 0, we have 3x, because x plus 0, 3x plus 0 is 3x, equals 6. And what would I do to solve for x? So I get x equals 6 divided by 3 is 2. Excellent. And so on our table of values, 2 goes in for the x because we already know that y is 0. That's what we just substituted, y equals 0. And we, by the way, we call this our x-intercept. Anytime you have y equals to 0, you're going to have an x-intercept, and that'll become more clear when we get to graphing, but I just thought I'd throw that out there. And these are ordered pairs, so x comma y, and that order matters. X always comes before y, and since we solved for x. Now, because we can have an infinite number, I could plug in so many different values of x and keep solving for y. And I could do that an infinite number of times. Well, I can't physically do that an infinite number of times, but theoretically I could do it an infinite number of times. So here we have x is equal to 4. So where am I going to put that number in my equation? I'm going to plug it in where I see x, because I have x is equal to 4. I want to find out what y is. Plus 2y equals 6. So what would be my first step to solving for y? How would I find y if I know that x is 4? Yeah, we'd multiply this. How we said? 12 plus 2y equals 6. You see how this is actually so much harder? When I had x was 0, it just bam, went away like magic. Now I have to actually deal with the 12. So what can I do to get y by itself? What would be your first step in solving? Subtract 12 from both sides. Is that what you said? 2y equals, what's 6 minus 12? Good. And then what can I do to get y by itself? Yeah, by 2, divide by 2, and I get y equals negative 3. And so I go to my table where x is 4 and y was negative 3. And by the way, that's the ordered pair, 4, negative 3. Okay. What about when y is 6? What would you do? Go ahead and try that out. And we'll share out. So y is 6. What did you do? Can you see the green? 3x plus 2 times 6, right, equals 6. And now what? I'm solving for x. I want to know what is x. 3x plus 12 equals 6. Next step, subtract 12 from both sides. We get 3x equals negative 6. Last step. Good. And we get x equals negative 2. So you see where I have 6 in the table, that was my y value. I'm going to put negative 2, and my ordered pair is negative 2, comma 6. Okay? So let's go ahead and go through some of these questions. 3x plus 2y equals 6 is a linear equation in how many variables? 2 variables. We need an S on the end. True or false? There are infinitely many solutions to the equation 3x plus 2y equals 6. What do you think? Also true. True or false? Solutions to the equation are in the form x, y, and that's basically what we call an ordered pair. Yeah, also true. Circle the solutions to 3x plus 2y equals 6. So far, we know that this is a solution because it's from our table and we already solved. This is also a solution, negative 2, 6. Is 0, negative 3 a solution? I went in a different order. Why would you say no? Exactly, because here, if you could plug it in, you could plug it in to see if it would work. Or if you look at the table, it was a positive 3, so that one's not a solution. Is 2, 0 a solution? Yes, because that one also is in our table. Okay. Let's go on to the next page. So if I give you an ordered pair, can you find what's missing? So in this order, which do you have, x or y, if you're starting with 4? 4 is x, and y is our mystery number. So if I know x is 4, I can plug that in, and I want to solve for y. So I get 2 times 4 minus y equals 8. How would I solve that for y? First step? Yep, minus 8 equals 8, or minus y, sorry. Now think about this for a minute. If you have 8 and you subtract some number and you get 8, do you have any idea what y probably is going to be equal to? Probably 0. But let's double check by going through the rest of our process to solve, and you might need more space. So what would I do to get y by itself? Yeah, so I get negative y equals 0. Now, a lot of times this will throw people off because they're like, well, wait, if I get 0, what do I do? Well, you put the 0. Now, what could I do? Is y technically by itself? No. So what would you do to get y by itself? Divide by negative 1, and you get y still is 0. So since the y is 0, we're going to call this an x-intercept. Anytime you get a 0, you have an intercept. One of the numbers is 0, it's an intercept. If y is 0, that's an x-intercept. If x ends up being 0, okay, so let's find out what about this one. If I want to solve, I know that y is equal to 4. I want to solve for x because this always goes in the order x, comma, y. If I know that y is 4, I'm going to plug in 2x minus 4 equals 8. Does everybody see where I got that? Now I want to solve for x. What should I do to get x by itself? Add 4. Is that what we said? 2x equals 12. What's the next step to get x by itself? I have room now. Divide both sides by 2. And so I get x equals 6. Since neither one of these points, these numbers are 0, this is not an intercept. It's just an ordered pair. 6, 4 is the solution. Okay, circle the solutions to the equation. So we already know that 4, 0, we solved that. We got this solution, 6, 4. Does that mean 4, 6 is a solution? Well, we would actually have to check and find out. It might be, it might not be. So let's actually do the math. If we plug in 4 for x and 6 for y, does it work out to equal 8? So that'd be 8 minus 6 is 8. Is that true or false? That's false. So that means this is not a solution. What about 0, negative 8? Well, again, we could plug it in, or we could plug in just the 0 part. X is 0, so 2 times 0 minus y equals 8. Now that is gone, right? 2 times 0 is 0, minus 8, or negative y equals 8. What could I do to get y by itself? Divide by negative 1. Y equals negative 8. So this would make that a solution. I could have either plugged in the x and y or plug in the x to solve for y either way. Okay.